Hi everyone. So today we'll be discussing about APIs and requests in this session. But before going into this session 4, right, let's discuss the solution of the problem, right, which we left with in session 3. Okay. So this was our problem, right? We have some raw logs, right, and we have an inventory and some of these devices are critical, some of them are not critical, right? Then we have to build a kind of dictionary, right? Of basically the log events which are occurring on critical devices versus which are not occurring on critical devices. Okay, so um, you, I have imported a couple of modules here, right? This is RE for regex. I've imported JSON and YAML, right, which we discussed in lesson 3 itself, right? And this is a function I have written for load critical devices, and I'm giving it the YAML path. Okay, this is a function. This is a parameter passed to it. I am opening that file with in the read mode, right? And this is safe load, as we discussed in the last session. It's better that we always use safe load in YAML, and then I'm returning the host names. Okay, this is the log pattern. Okay, where I am matching specific things, right? For example, I'm matching the timestamp, I'm matching the host name, I'm matching the facility, severity number, mnemonic, and the message, right? You can see it in detail, right? Uh, uh, I'm matching numbers, spaces, characters, and all of those things, right? And I have given this is a dictionary, and in this dictionary, I have mentioned key value pairs. Zero is emergency, one is alert, like that, right? And I'm compiling for interface. I have this pattern, right? For the log, this is the pattern. This is the pattern for interface. Okay. So then I am parsing the log file here, right? I've given it the log path and I've given it the critical devices list, right? And based on it, it is giving me all the details from that log file. And here I am doing the summarization. Okay. And I'm basically here I'm running the whole pipeline, means first loading the critical devices, then parsing the log file, right? And then dumping all that in a syslog report. Okay, so these are the details. I'm not discussing it in very line by line, right? Because the assumption is that after going through first 3 sessions we should be able to write most of the code which is present in this solution, right? Today then we'll start with our module 4, right? Which is API and requests. Okay. As we discussed earlier that going ahead from this module, we will do all the development locally, right? Earlier, this development was being done through uh, this Google Colab, right? And but Google Colab is kind of a pre-built environment, right? Generally, we will do local development, and we should be aware how that local development is done, right? So a prerequisite for it, this is that you should have Python installed in your system. Okay, installing Python is very easy. Okay, you can just do installing Python on Windows, right? And you will get how to download it and then just basically install it. If you have Mac or Linux, right, it should be easy to do it similarly, right? Just search how to install Python in your web browser and should be pretty simple to install. Okay. After your Python is installed locally, right, we should be ready to start this session. So in video 4, we are talking about API and requests, right? Why this module is important? Because any automation you are doing, right, many times you will have to deal with some external tooling, right? For example, you might have to talk with some Meraki dashboard. Might have to talk with Cisco DNAC, ACI, right? Uh, Arista eAPI, right? Maybe you might have to talk with uh, any third party or any external data source, right? Which data in a particular format. Okay, so All of those will be talking in some format of API, right? There are some older techniques to communicate with these kind of third party or external systems, right? But API is kind of contract, okay? A contract between the that service provider, for example, Meraki dashboard, and a contract between us. And we understand that if you send me a data in a particular format, right, we will be able to consume it. Okay. What are the details of that contract? Okay, we will see it in this session, but it is basically a particular way of providing the data, right? And they also define a way how to request the data. Okay, so if we request the data in a particular format, in a particular with by sending some specific data, they will reply back with some specific data requested. Okay, how we requested it. Okay, so let's start with fundamentals. Okay, so HTTP basically works on a server client model. Okay, so it is a request response model. Okay, so client sends a request. Okay, so when from our perspective, client is Python code, right? So Python code will send a request, and from another side, server will send a response. So server is whatever, maybe DNAC is server, NXOS API is server, right? Or whatever is the other third party, or the other service you are using, right? Those are the servers. Okay, and they, from their server side, they will maintain the responsibility of sending the response. Okay, but client should send the request in a particular format. Okay, what is the format? So uh, a request has four parts. Okay, first is the method. What do you want to do? Do you want to get some data? Do you want to put some data, patch some data, or delete some data? Then you have an URL. Okay, so URL is the resource you are targeting. Then you will send some headers, right? Headers in metadata, auth tokens, content types, etc. Then you will have some body. Okay, the body will be the payload. Okay, for example, you want to send some data, right, to an API. For example, you can create resources, you can create uh, provision devices or something like that, right? Through API. So there you will have to send some data, post some data, right? You don't have to get data, you have to post data there. So all that data you can send it from the board body. Okay. What does that a responding party or the server responds to? Okay. The server will respond with a status code. Okay. Status code is basically what was the how did your request go? Okay. Did it succeed? Did it fail? Why it failed? Right? All of that data will be in status code. Okay, it will be basic number. Okay, but that number will point to a specific thing. Okay, we'll talk about what are the what specific number means. Okay, headers, they will also send some headers with metadata basically, and then you will have body. Okay, the body will be usually JSON. Okay, so if you requested something, so they will send that data in the body. Okay, in older systems, XML can also be used. Okay, uh, but generally JSON. Okay, so HTTP methods, as we were discussing, right? These are the method. Okay, so now we'll discuss each of these 7 8 things in detail. Okay, one by one. First thing is HTTP methods. Okay, the first method is get. Okay, get is to read data. You want to get some data. Okay, from the other side. Okay, uh, this data can be different based on different constructs. Okay, for ACI it can be something else. For NXOS API it can be something else. For DNAC it can be something else. For Arista it can be something else. Right? For ServiceNow it can be something else. Okay, but just understand that if you want to get anything from the other side, get something from the other side, you will have to use get. Okay, if you want to create any new object, okay, that object is not existing. Right? For example, you want to provision a new device. Okay, you will have to use post. Okay, you want to create a new VLAN maybe, right? Or you want to add a switch to the network, right? Maybe say in ACI you want to add a leaf node, right? So you can use post. Okay, that is post is always for creating a new object. Okay, put is patching something, okay, or adding something, overwrite an existing configuration. Okay, so put and patch is different. Okay, now say put is for replacing a full config. Okay, so you have a device already running, right? And say an XOS switch already running, right? But you want to replace the entire configuration. You want to wipe the older configuration, replace it with a new configuration, right? But that device is still existing. Okay, you don't need to provision new device, right? That object is existing, but you want to put a new configuration on that uh, uh, existing object, right? You can use put, but you don't want to change the entire object, configuration, right? You want to just patch particular fields, right? For example, you want to change the VLAN name, right? Or you want to change the host name of that device, right? You can use patch. So this is the difference between post, put, and patch. Post is creating that object. Put is replacing the all the contents of that object. Patch is replacing a specific part, a specific configuration, a specific portion of that object. Okay. Delete is you want to delete a specific thing. Okay. Now you're talking about status codes, right? Which our server will respond with. Okay. So these are numbers. Okay. And we number will associate with something. Okay. 200 means okay, succeeded. 201 means created. Okay. We sent something to create, they created it. 204 is no content. The status is succeeded, but nothing returned from the server side. We don't want to return anything. Okay, no data need to be returned. Okay, for example, you deleted something. After delete, now the object is not existing, right? So they can respond with 204. 400 is bad request. Okay, so 400 is important because if you're sending your request in a bad format, right? For example, JSON body is not proper, your parameters are not proper, right? For example, from the other server side, they want a specific parameter like username and password, but you're not sending those parameters in body, then they can send a bad request. Okay, 400, 401 is unauthorized. Okay, so unauthorized, we will discuss what is authorization in detail, but we have to understand that API, all APIs will not be open, right? For example, when you are logging into any Cisco device, okay, through a terminal, right, you have to enter a username and password to authorize yourself, right? Similarly, your API will also have some authorization mechanism so that when you are sending a request, they know that you are the right person sending the request, right? Otherwise, like how there is a security problem with a physical box, there will be a security problem with these APIs also. Okay? Many people will try to send API request, right? Unwanted API request, right? Or there can be a DDoS attack on this API request. Okay, so you 4.0 unauthorized means you are not authorized, or unauthorized means either you are sending the wrong request, okay, so wrong details for authorization, or maybe your authorization has already expired. Okay, anything can, but you basically you're unauthorized to do it. Okay, 403 is forbidden. 403 and 401, 401 means you have the permission, but you are not sending the right credentials. 403 is you are sending the right credentials, but you are not allowed to do this. For example, with specific, for example, with a create API, right? You maybe you want only admins to create, to have access to create API, right? But you can give, you want to give access to the patch or put API, right? Or something like that to specific developers. Okay, so uh, there will some we have something like access, right? Access levels. So forbidden means maybe you are a developer, but you are trying to access something for admin. So there will be forbidden. Okay. Not found is wrong URL. 429 is too many requests. Okay. So normally your APIs will be rate limited. Okay. Rate limited as in within a particular minute or within a particular hour, how many requests you can send to that API, right? It can be complex calculations also, but basically you are sending too many requests. Okay, this is basically to prevent any DDoS attacks, right? Because at the backend there is a server which is serving to all these requests. Okay, so if you start sending maybe many requests, right? That server can get overloaded, right? Anything can happen. So basically it is rate limited. 50500 is your internal server error. Okay, so your server was doing something and uh, server broke. Okay, something happened on the server side. It is not generally your issue with you. Okay, you are authenticated, you're asking the correct resource something, right? But the server broke somewhat, right? Generally, you will do a retry. Okay. 503 service unavailable. Service unavailable means service is all overloaded in maintenance. Okay. Generally, server is overloaded basically. Okay. So if server is overloaded, maybe you try after a little while. Okay. Uh, let's discuss this part and then we'll go with our first uh, code here. Okay. This session we are doing a little bit different, right? We have all the code files separated. Okay. So we'll discuss all the code files separately. Okay, you can run them individually and learn about them. Okay. So REST APIs, REST is just basically built over HTTP. Okay. Most of the devices now are allowing REST APIs. Okay. You have we saw now, right, that you have URLs, you have HTTP methods, the data is exchanged in JSON. and APIs are usually stateless. So, okay, so what do you mean by stateless? Okay, so API will be stateless means you requested something from the server, okay, from the other side, for example, say from DNAP, right? Next time you cannot reference the old object. Once that data is sent back to you, that state is what you can say, that state is released, okay, or that state does not exist. Okay, for example, you created an object, say, right, in the last in your first request you created an object, say object XYZ, right? Now you did not store the name of that object, so when the data is returned from the server side, you did not store the name of that object, right? Now in the next request you are trying to reference the older object, right? Thinking that from the other side, server will be able to remember that I referenced this XYZ, I created this object just now, right? So it does not work like that. REST APIs will not work like it. It will be stateless. Okay. So if you want to request that object again, you have to again give it the name XYZ. It will not remember, the server will not remember that you just created this XYZ object just in the first request. Okay. In the second request, if you want to get that data, you send the name back. Okay, so all the requests are what you can say, uh, you send the request, you get the data back, and then that and there the state, all the state is finished. Okay, the server does not maintain the states between the APIs or API request. Okay, usually. Okay, now let's go and see the first uh, our code, right? So uh, just we will not discuss everything in very detail, okay, because we have 11 files to discuss, right, along with the theory. So the assumption is that with the three sessions which we have done earlier, right, we'll be able to read most of the code, right? But I'll relate with whatever theory I'm doing, right? So this is the URL, right? And I will discuss with the requests about the request library, right? Request library is a basic library which we can use for using for doing HTTP based requests. Okay, basically REST API is working with REST APIs, right? So this is the URL, right? We talked about the URL, right? And I'm sending the request. Okay, I'm sending the request with URL as the data, this URL, and I'm saying timeout equal to 10 means a timeout in 10 units. Okay, I'm printing the status code. Okay, so I got the response, right? So this is the response. So response will have multiple things, right? It will have status code, as I said, right? Okay means it is true if it is giving it us to 200 code, okay, 2 something code. So if it is 400, 300 in range, 500 range, it does not means it is okay. Okay, so then I am parsing the text, right? You can convert it into JSON better, right? I converted it into JSON. I am printing the origin is basically one of the uh, metadata, right? I am printing some of the response headers, okay, and I am printing the all the response data. Okay, so let me get the terminal here, and then we'll run this code. Okay, Python 01. So once you have Python installed, right, you will be able to run any command like Python. Python means run this file using a Python compiler. Okay, so or a Python interpreter. Okay, so I did this. Okay, what it did is it took this HTTP request, right, and this request library basically sent a request to that HTTP URL, right, and the status code is successful. We are seeing 200 means successful, true, right? This is the response text. This is basically a text file. Okay, response JSON we converted into JSON, right? Once we convert into JSON, we know that it becomes a dictionary, right? It parts into a Python dictionary, right? This is the origin we printed. These are the response headers we printed, right? And this is the header request, headers response sent to us. Okay. So you see there are a couple of things, right, which we discussed just now. How basically a API request is formed and how the response is coming from the other side, right? So those are all the details, right? We have the URL, right? And we got some HTTP data back, right? And we had we can convert it into JSON. Okay. Now we have you can read any API documentation, Okay, so API documentation, reading and understanding and reading an API documentation is important, right? So, for example, let me bring uh, this back. Okay, you can go online and search about any API. Okay, you can get API reference for basically anything. Okay, you want to learn APIs for maybe say DNAC, ACI, NXOS, anything, right? You will get it the documentation online. Okay, so what all things you have to think when you are reading and documentation is first, what is the URL I need to access to? Okay, for example, here I need to access this URL, right? So I need to know which URL you have to access to. Okay, second thing is I want to know um, what is the authentication schema basically, right? What authentication do I have to send? There are a couple of authentication techniques. One is bearer authentication, basic auth. There are multiple others, right? But I'll be talking about a couple of them here in our uh, third code file, right? What is the endpoint method, right? For which endpoint, what kind of method work, right? Not all endpoint will work for all methods, okay? And what all required or optional parameters is requested, okay? And now we use the request library, right? So we will have your own, you can use the URL lib also. So URL lib is, you can say, very low level library to do the same thing which request is doing, right? But request is basically more easier and to work with, okay? uh, get request we did, right? URL lib or something raw socket, we don't need to work with that, right? Working with request is way easier, right? So how will your request look like, right? We'll see in session, we'll see in the code too, right? But you can send some parameters also, right? Find all the parameters here, right? The site status, right? And then pass it in this params. Params is equal to, so we can name it anything, but this name should be params only. Okay, and the request will handle all the URL encoding and everything for us. Okay, then we have headers, right? In header only we will have the authorization and all. Okay, so authorization I'll be talking about bearer authentication here, right? So in bearer authentication you will have a token. Okay, and that token I will show you how to generate it for I'll show you how to generate it later for Meraki dashboard. Okay, but basically you are provided one token from the other side, right? From the server side, that if you use that token, then the server will understand that it is you as an user. Okay, and it will authorize you to it will authenticate you also and authorize also you to run specific things. Okay, and we know that we can do post also, right? You see that this is post, and we can do patch everything. Okay, now let's see in second. um, this is our requests, right? Same thing. I have a base URL. Okay, this is how I do get I just showed you, right? This is my base URL. I am doing slash get parameters, I'm sending something. Okay, and this is my post, right? In post I will have to send some data also. Okay, so I'm using JSON to send data. Okay, basically it will create it and send us back, right? Put, I'm sending slash put, right? Again here I'm sending JSON, right? Then here I'm doing patch and again sending the JSON. So data is same in the JSON, but you see the URL changes, right? Slash post slash put slash patch. So based on this URL, the other side, the server will understand what exactly you want to do, right? This is also a different, right? Post, put, patch. These methods are also different, but here the URL is also different. Okay, many times the URL will be same and the URL will be same, and from here we can do it from the methods we can do put, patch, uh, post, put, and patch. Okay, and here I'm doing a delete. Okay, so now let me run it. It is doing get, then post, put, patch, delete. Okay, everywhere you are seeing 200 means successful. Okay, so first I did get a site, Post I did. So even in post, what I send, it is sending it back, right? What new object it created. Okay. And put, it replace the entire object. Okay, with a new object. Patch, it just patched the server name, right? And deleted the whole thing. Okay. Now we also discussed about authentication, right? So this is not a real, this is a fake, or you can say, for Meraki, I've used a fake authentication mechanism here. Okay, we'll use a real. I'll show you how to do the real things also in file 10, right? But here it is just fake. Okay, and here you can see that the header will be something like X Cisco Meraki API key. Okay, and here I will use the API key. This will be my key. This will be my value of the key. Okay, how will I know that this is the name I have to give for the key? This will be in the documentation. Okay, that if you send us the key in this format, okay, name should be this and then the key value, then we'll accept it as a key. Okay, if I send it something else like just Cisco Meraki key, it will not understand. Okay, the server will not understand. Therefore, I'm saying this is a contract. Okay, server will say to you that I need data in this particular format to send you something back. Okay, and it will then properly send you back according to the REST APIs the contract. Okay, then this is an API key, right? Similar to it will be a bearer token, okay? But in bearer token, your key will be authorization, okay? And in bearer, and then you will have a bearer token here, okay? Otherwise, we can have your normal username password authentication also. Depends on the API implementation, okay? Below, I have just shown how to post, get, and put everything, right? But just the important part to understand here is that the authentication mechanisms can differ. Okay, it can be simple API key authentication, it can be token, it can be username password. You have to read the API documentation to understand. Okay, and the implementation varies a little bit. Okay, so not running this file again because it should run. Okay, same thing I'm doing, right? But all different authentication mechanisms. Okay, let me go next to how to handle JSON. Okay, now not discussing this in much detail because we have already discussed about JSON, right? The data which is returned to us from the API is in a JSON format. We can convert JSON into basically a Python dictionary, right? And then start using it. Okay. So here what I'm doing is this is my mock API response, right? So I'm just mocking the response. Okay. Don't till 9 everything is mocked. Okay. So this is my API response, right? All the data here from which I'm getting from the API, right? Uh, Once I get that data, I can easily convert it into any dictionary in Python and start using the dictionary, right? Normally, how we can use it, right? We can use keys to get it, right? We can use for loop to get all the keys and values, right? Normal, like how dictionaries work and how JSON works. Okay. The important thing to understand here is that most of our APIs will return the data in JSON. Okay. So we should be aware that how JSON handling is being done. Okay. So if you don't know how JSON responds, how JSON works, right? You can see the session 3 where I've discussed JSON and session 2 where I've discussed dictionary in great detail. Okay. So from there we'll understand how to convert your data, text data, whatever data you are getting from the other side, JSON data, what you are getting from the server into a proper dictionary and then start using that dictionary in your Python code, right? Authentication method we just discussed, right? Either you can use an API key, bearer token, HTTP authentication, OAuth 2 is also there, right? Depends. Okay. Your in the documentation of the API, yeah, you will understand that what kind of authentication does it takes. Okay. But all of the APIs, right? Only these fake APIs or faked APIs, right? Where I'm using it just for testing, you might not have authentication, but all real production APIs will have authentication. So understanding authentication is very important, and reading the documentation to understand the authentication is important, so that we know what are the authentication methods, but which authentication methods are supported by an API. We will only get it in documentation. We cannot make a list that for Meraki this is used, for ACI this is used. That will be difficult, and it can be ever changing, right? Then error handling, timeouts, and retries, right? So uh, API, as I said, one is it is stateless, right? And it is not 100% that you will always get data from the other side, right? Because there can be server error, unreachable, maybe you sent the request, but while getting the request back, your network went down, right? Any DNS failed, something like that, right? Or anything can happen, right? So you should have a proper error handling in place so that you can accept the response, whatever you're getting, understand what response you're getting, because you have different 300, 400, 500 ranges where you will understand what kind of issue is happening on the server side, is happening on the other side, and then you can handle it based on that. Okay. Uh, you can do retries, right? You can do timeouts. That way, if I don't get data in this much amount of time, right? That I'm saying always set a timeout, that you should expect that data will come in 1 minute or 2 minutes from other side, right? If your data is not coming in 1 or 2 minutes, it is not a good design that you completely wait on requests. Okay, because request is if it does not uh, what you can say, if your data is not coming from the other side, it will hang there at the requests, wherever they were making the request. Okay, so you should always do a timeout so that there itself you handle that requests. Okay, whatever you're sending to the other side. And if you know it is not working, it gets timed out in a particular time. Okay. Now you do retries with backoff. Okay. You know that 429 will be used for rate limiting. Okay. But we know that our server is doing rate limiting, but how to handle it from our code perspective, right? You can do retries. Okay. Now don't do retries immediately. Okay. Immediately, as in after 30 seconds, do again a retry. After a 30 second, you again do a retry. 30 second again do a retry, right? So your server are maybe it can happen that your server is loaded because of your requests. Okay. Or maybe there are too many requests, and if you do it after every 30 second, again you will get transient failures, right? Again you will get 429. Okay. So better you do something called as exponential backoff. Exponential backoff is you try in exponential increase, right? Maybe you start with one, right? After you maybe you say you retried after 1 second. If it did not work, next time you retry after 2 seconds, right? If it did not work, next time you retry after 4 seconds, 8 seconds, 16 seconds, 32 seconds, right? This way there is a better chance that your server will be responding to you without one of these errors. Okay. This is one of the mechanisms. It's not like you have to use it, right? It's better if you use it, if you're doing it by exponential backup, right? Now there is a thing called as sessions. Okay, we'll discuss all of the codes also, but I want to get the theory clear. One of the things is sessions, right? Now say you authorized once and you sent a get request, right? But did not store the session anywhere. Now again, next time you have to again for next put request, next post request, next get request, you have to again send a new request. Okay, with again with all the authorization and everything again, right? So this what it will happen is you will have to again start from the basic authorization process once again. Okay. So it's better if you authorize once. Okay. So create a session and then send that to that session whatever requests you want to do. Okay. So this what will happen is authorization is handled once, and then later you are just using that authorization to send get request, post request, put request, whatever request. Okay. It will be faster. Okay. Next is pagination. Okay. So pagination is maybe say you have 1,000 devices in Meraki, right? it is not possible that if you're asking for all the use, maybe say the device names, how many interfaces are there on it, or something like that, right? For 1,000 devices, it can return all of their data in once. Okay. First of all, it will be slow, right? For returning 1,000 pieces of information and then all the JSON for that 1,000 data points at once, right? What you can say is you can send a pagination, or most of the servers will have pagination, right? Where you can say that I want send me page by page, and per page you send me 100 uh, 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 in 100 data points basically. Okay, or for our example, 100 devices in one page. Okay, so we'll talk about how pagination is done in the ninth one, but yeah. Uh, then SSL verification and self-signed certs on network gear, right? Uh, so you will have all of these DNAC and everything, right? Cloud APIs will have their own public certifications, own public certificates, so no problem, right? But if you're having, you're building REST API on your own, right? This is I'm talking from the server's perspective, right? If you are having REST API which are running directly on your own switches or routers, right? They will have generally their own self-signed certificate, right? They will not have a public certificate, which will be with our normal cloud API or public websites, right? So there you will, when you are doing the request, right? It will error with SSL error, right? Why? Because underneath REST API, it is using HTTP, and under HTTP, it is using SSL, right? For all that authentication, security, and everything, right? So you will get this error, right? In lab, right? In lab also you can get this error if you're doing requests to your maybe say to some your local REST APIs, right? So there you can disable this warning, right? And you can do verify equal to false, but this is not the right thing to do. Okay, in production you should install the device certificate to your system, right? And you point it to verify. Okay. For example, you can store the PEM in your local file, local system, right? And then you can use verify to use that PEM and then verify based on it. Okay. So these are all the things which are surrounding the REST APIs, right? Now, JSON handling we talked about, headers and params, right? Let's talk about that. So this is the parameters we talked about in third also, that we can send some parameters, right? And that parameters will be basically key value pairs, right? Like this. We can send headers also. We talked about authorization, which is basically a header type. Okay. Content type, you can say I want application JSON format, right? And then normally you will say you will set these two things. Okay. Accept content.json, content type should be application.json. Sometime it will be application.xml also if you want the data in XML, if your server also supports it. Okay, all this will be in documentation. Payload is your data, right? For example, I have VLAN ID, I have name, I have subnet, right? I am posting this, so I have the URL, I have sent the parameters, right? I have the headers, and this is my payload which I'm sending in JSON equal to. So remember that JSON is your payload, okay? And this is my timeout, okay? Whatever response I got, right? I am printing that data, okay? So Python 05. Okay, this is my JSON body server received, and this is the authentication header. Okay, cut. So this is how I'm doing headers and parameters, sending headers and parameters, right? Next is error handling. Okay, so error handling and doing retries. Okay, so what I've done is I've created a method called as safe get. Okay, I am sending the request, right? And this time a request is with particular timeout. Okay, this is my timeout 5. Okay, a response raise for status. Okay, and you will get if you will get 400 or 500 error from the other side, you will get an HTTP error. Okay, so it will convert your 400 and 500 into HTTP errors. Okay, so if you get 400 or 500, basically it will not go in try, it will go in accept, right? Because 400 and 500 are converted into HTTP errors, right? So you will get either timeout right? You will either get connection error, HTTP error, or value error, right? So based on that, you one in under one of these it will fall. Okay. So you are calling this safe get, right? So this is the basic try except, right? Where you are handling everything. It should not happen that you did not handle this and here your code gets broken, right? Here your code will get broken. Otherwise, this will work and it will return none. Okay. Here you're doing manual retry with exponential backoff, right? I am doing it with manual retry, right? I'm saying I have to maximum attempt 3 times, right? I do a request get, right? And I will increase the time raise for status, right? And you can see wait is 2 times the attempt, right? I'm increasing the wait. And after waiting for that amount of time, I am retrying it again, right? So this will retry it after specific wait time. So it will be 2 second, 4 second, 8 second, 10, 12, 16 seconds, like that will increase. And after that amount of time, waiting for that amount of time, it will again do the same uh, calling the same API. Okay. Or I can use the retry uh, uh, function from this module, right? And retry object, right? And in that retry object takes how many total time I have to try, what is the backup factor, for which states I have to retry, right? And what are the allowed methods, right? And then I can pass that um, based on this retries, right? I have to pass it in the retry strategy, right? And then based on that, it will do the retry. So first, either you can do normal try except, right? Or you can implement your own exponential backoff, right? Some simple kind of thing, or you can use already existing Python implementations to do that same kind of backoff, right? Exponential backoff. Better to use what is already implemented in Python, right? Because it is tried and tested, and we don't have to invent the wheel again, right? And it will be more robust. Okay. So we have that kind of implementation as I talked that APIs will 100% time get you give you the data. That is not the correct assumption. Okay. So this is an important part that we do error handling properly. Then we talked about session, right? So this is my session I'm creating, right? This is without session. Okay. So every time you have to run something, you have to again negotiate a new session. Okay. I am creating a session here, right? And then I'm using that same session to do other calls. Okay. So what will happen is you don't have to use don't have to give the same authorization again and again, right? That authorization is done once, and then you can use the same session again and again for calling maybe multiple times. You can use get multiple times. So if you have maybe say 10, 100,000 of devices, right? You have to negotiate all of that authentication 1,000 times, right? So better we stood it in one session and do authentication uh, for all those 1,000 things. Then we talked about pagination, right? So uh, pagination is basically you want only specific part of data, right? You don't want all the data at once, right? Maybe because it is slow, it is, or it's easier for us to, from the client side also, it is easier to handle chunks of data which we know that, uh, say we have 1,950 devices, right? If we say that I want 100 devices at max, that we know that we will get maximum 100 devices, and then that is more easier or more better to work, right, from the client side. Okay. So this is an implementation of how we can do pagination. Okay. I'm sending max pages 5, right? And all of this is a normal Python code, I think, which we can understand. Okay. The main thing is understanding these uh, things which are around the REST APIs. Okay. So the REST API is not only about how to send the data and get data back, right? It also includes that how we can authenticate it, right? And handling errors, sessions, and pagination are core topics. Okay. If we understand them, right, working with APIs will become more easier. Okay. Now, we'll go ahead with one of the Meraki, right? One of the Meraki examples. Okay, so I'll first show you how to generate a key, right? API key basically. Okay, so for this example, I'm using DevNet Sandbox. You can use it too. I will give it I'll give a link to this specific sandbox which I'm using for this example, right? You can do a lot of things, but I'm doing very specific basic things only. Okay, but very powerful. You can do a lot of things, explore a lot. Okay, you can use this DevNet Sandbox. Okay, this DevNet Sandbox will also give you access to a Meraki dashboard. Okay, like this. In this Meraki dashboard, I went to organizations, configure API and webhooks. Okay, there are a lot many things you can work with. You can see what all power, what all features that is Meraki providing. But for our use case, we want APIs, right? So I'm going in the API and webhooks. I created a API key, right? I generated an API key. Okay, and then I stored that API key. So I have two API keys, right? I can revoke these keys. So this basically key means authentication mechanism. Okay, so if you provide this key in your request, it will understand that yeah, this is my user. Okay, so I will revoke. You can revoke a key also. Revoke means this key is no longer valid. Okay, I'm revoking the other key because I already have one key working. Okay, this key understanding is important, that this key is a security thing. Okay, we don't have to expose this key to anyone. Okay, if it is in production, I will show you now. I will revoke that key later, but yeah, in production this key should not be shared with anyone. This is a secret. Okay, and how to store a secret in Python. Okay, that I have not discussed here, but you can search it online, right? What are the different ways how I can store secrets in Python? Okay, so in what a couple of things. Okay, first is never check out your if you're using GitHub, never check out these API keys in GitHub repositories. Okay, for that you can use gitignore. Okay, you can learn about .gitignore files where you are maybe you can store it in .env. Normally we will store it in .env files, okay, which are environmental variables. And then we can we don't have to those will be stored locally. Don't push it on any Git or anything, GitHub anything. Okay, for that we can use .gitignore, which will ignore that .env file. Okay, first thing. Second thing is store it in maybe when you're doing local development, you can store it in .env, right? But in production, many companies will have some authentication vaults, right, or some mechanisms, and then you can get your API keys or whatever from that authentication sources. Okay, so there are multiple ways to store it, but the understanding is that this API key is a secret, okay, which has to be stored very properly, because then anybody who has these API keys can make the request. Okay, so I'll be showing my API key, no problem, but I will be revoking it later. So this is my requests, right? This is my base URL. Okay, so from where I'm getting this base URL, I can get it from the documentation. Okay, same API key. I'm doing a get session. Okay, so I'm creating a session. I'm using this API key. API key is exact API key which I showed you earlier, right? Then I'm creating a session. In the session, I'm sending a header X Cisco Meraki API key. Okay, so this is the API key. I'm sending it to the Meraki dashboard. And should understand from there that if this API is correct and it is not revoked, it is working properly, then that means I am the correct user and I can do all the requests. Okay, and content type, I want the content in application.json. Okay, and I am then you doing list organizations, list devices, list device status. Okay, and I am basically calling these printing all of this. Okay, the important thing is from where did I get this, that slash organization ID slash devices will work, base URL slash organizations will work, right? Slash organization device statuses will work, right? This I understood from the documentation. Okay, so understanding, reading the documentation before starting development around API development around anything like Meraki ACI is important. Okay, you read the documentation very detail, understand what all functions, what all methods, what all APIs are supported for that specific platform. Okay, and then you can start using it. From the documentation itself, I understood that it is taking this X Cisco Meraki API key, and I can authenticate via a token. Okay, in some there the token won't be allowed, only bearer authentication will be allowed. In some username and password will be required, right? So they're different. For Meraki, this is the way we can do it. Okay. Now let me run this, right. So it went, see, this is the power of API, that I did not have to touch the device, right? I got all this data from the API, right? I made an API call, which was Meraki was exposing, right? I can do the same thing from dashboard also, right? I can go and check from the this dashboard also, all those same things, whether devices are online or not, right? What all devices do I have in my network, right? And what are the name of all those devices, right? But my API made very easier to get all those data and then process it, right? So this is how I can work with Meraki APIs. I will put the link of this in my YouTube description, so you can go ahead and start looking at it in more detail. Okay, you can read the documentation of Meraki. As I said, no two APIs will be same. Meraki will work differently. Your Epic ACI will work very differently. Your NX API will work differently. Your Eastern Juniper or other vendors, Huawei or Nokia will work differently, right? But the core concepts remain same. Okay, what we're discussing today, the core concepts will be exactly the same, right? But how are those implemented will be different in different APIs, and that we can only understand from the documentation. Okay, this is one of the larger uh, uh, code I have written, right? Taking all of these things in consideration, right? So whenever you are creating any API, right, for your production use, right, it's better if you create it in a more structured, in a more by taking everything into consideration, like how are we using sessions? Are we using error handling? Are we using proper JSON handling? Are we using paginations? Are we using security? Right? Everything into consideration, right? All the good practices of coding, which we have been discussing, right? Also, you have to put it in perspective of APIs also, and then we can use. For example, you see that I've created functions for all of them, right? And I'm using functions to I've made a class that, and in that class, I'm using functions to do all kind of requests, right? And there are some other safety related things related to URL also, right? That if you're exposing this, maybe say you are exposing a put request for your users, right? Maybe you are doing some development in the middle, right? Like you are a middleware. So you will take data from DNAC and you will allow users to see the data, right? So you will allow, as a company, will allow users to put or patch that data through you. You are working as a middleware, right? So it's important to understand that what information will be shared by the user, right? So there is something like SQL injection and all of those things, right? You have to be aware about all of that. Okay, that there are many security constructs around APIs, right? Around this handling, how APIs work, how the data is taken from a particular source and then sent back to the server, right? There are things to understand that, and I have not covered that here because there are many things, and that will become in a very detailed session, right? But understanding the security point of view of API is also important. Maybe you can read more about it on your own, right? So yeah, this was all about APIs, right? Mostly about REST APIs, right? I'm not leaving you with any problem statement today, right? But next time, when in our fifth session, okay, we'll combine fourth and fifth as a single domain, and then we'll leave you in the fifth session with a problem statement to solve. Okay. But I will highly encourage that you go ahead with Meraki, you deploy own, right? I think this is available for you for 8 or 10 hours, something like that, right? At once, right? For after you provisioned it, you use it for some practice, and it will be a great. Apart from Meraki, I think there are other sandboxes also available on DevNet Sandbox, where you can learn about how to interact with APIs, right? So I will highly encourage that you do it. Thanks for watching this session. We'll see you next time.